Chapter 3 Study Guide, number 43 and 44, the directions say, for each combo of relationships, determine whether P and line S are parallel or perpendicular to each other. So there's only two options. It doesn't say or neither, so it should be one of the two. So let's start with line P. What does it say? It says line P. So I like to start with a horizontal line. I don't know why that works for my brain, but it does. Line P is perpendicular to line R, which means it crosses it at 90 degrees. So it tells us that. It's perpendicular to R. What do we know about R? R is perpendicular to S. So I'm going to draw in line S where it's crossing R. How is it crossing it? It's crossing it at 90. So there's line S. The question is, well then how are line P in blue and line S in pink related? We know that those are going to be parallel. We learned a theorem that says that if you have a line that is perpendicular to two lines, those two lines must be parallel to each other. All right, it gives us another situation on 44. Line P is perpendicular to R. So line P is perpendicular to R. So let's draw in line R. Line R, to be perpendicular to P, has to cross it. What angle does it cross it at? It crosses it at 90, at a T. But also says that R is parallel, which means facing the same way as S. So it's parallel. So I'm going to add those little triangles to show that those are parallel to S. Well, the final question says, how are line P, so that's going to be done in blue, light blue, and line S, which is done in pink, how are those related? Those are going to be perpendicular to each other. Again, we learned a theorem that said that if we have a line that is perpendicular to one line but parallel to another line, that other line, those have to be perpendicular. Why? Because if these are parallel, then these are corresponding angles. So this angle is going to be congruent to this angle, so we get to end up adding that there. All right, now we have our first proof. It says to complete the proof, and we have our givens. The first thing I'm going to do is highlight my givens and go ahead and get those free points so I don't miss any. So here's A is parallel to B. That is a given. What else is a given, though? It is also a given that 5 plus 2, the measure of 5, plus the measure of angle 2 is equal to 180. Those are free points. They give you those for a reason. If we're going to solve a problem, we have to have a problem to solve. What are we trying to prove? We're trying to prove that L is parallel to M. Well, why is that important? Because anytime you're trying to prove that two lines are parallel, I immediately know it's going to be the converse of whatever is written above it, whatever kind of angles those are. So let's go through it real fast. Start with what's given. 5 and 2, so I'm going to highlight those in blue. 5 and 2 add up to 180. That's given. And then they tell us that A is parallel to B. So it is given that those are parallel. Well, right below that, they make a statement about some angles that live on those lines. Angle 1 and 5 are congruent. Well, how do we know that? That is going to be because those are corresponding angles. That's our corresponding angles theorem. Those must be congruent because they're in the top right corner and the top right corner. Okay? If those are congruent, then we know that their measures are equal. How do we know that? That is the definition of congruence. That symbol allows me to say, hey, their measures must be equal. And then they almost go back to the original statement where 5 plus 2 equals 180. The measure of 5 plus the measure of 2 equals 180. But they replace the measure of angle 1, which is right here, measure of angle 1, they replace it, the measure of angle 5 right here is replaced with the measure of angle 1. Well, what is it called when we replace something? That is called substitution. We're substituting into an equation. And so they substitute the 5 to be a 1, since we know that that is true right here. And since 1 and 2 are supplementary, what can we say about L and M? Those are same side interior angles, which means that those add up to 180. And so if that is true, the converse of same side interior angles theorem tells me that those lines must be parallel. and you had to use the converse.